Okay, why? Because you can write instruction to the hardware. You can communicate to the hardware. And C language is very fast, is very robust. The reason why it's fast is it's closer to the machine. All right. The higher level you go, the more you are closer to the user. Okay. But away from the machine. All right. So it's very fast. C is versatile. You can use it to write so many, is used in so many applications. All right. You can use it in embedded system. You can use it to create different type of application software. Basically, C and its advanced counterpart, which is C++, is very robust. It's an industrial application language. It's an industrial language. All right. Your operating system is majorly written in C, maybe some part in assembly. Your operating system. Okay. Your servers, they are mostly written in C and C++. All right. Your graphics, all the graphics you see, they are majorly done in C, C++. Okay, all the applications like your Mozilla Firefox, your VLC, and all that, they are implemented with C and maybe C++. So it's very important for you to understand this, that as computer engineers, the language for engineers is C, and maybe with C++ for object-oriented programming. Very versatile, very fast, uh, very user friendly, and all that. And C has what we call a lot of libraries. Libraries are pre-written codes, okay, pre-written templates which you can use rather than you writing your own software. So you don't want to reinvent the wheel, okay? You don't want to reuse the program. So you just import those libraries and you begin to use them. All right. So enough of the talks. Let's see how we move on. All right. There are several recommended texts, please. There are several recommended texts. I won't want to bore you with a particular text, but we have textbooks like Sam Teach Yourself C in 24 hours, Teach Yourself C in 21 days. It doesn't matter. There are several texts online. There are several resources online which you can actually look at. Okay, so I won't want to tie you to a particular textbook. All right, so let's move on. So, before I will move on, we will look at how to start C, how to start using C. Okay, I might even abandon the slide as time goes on. How to start with C, component of a C program. Or the first thing we also need to do is what we call how to write a program or software development lifecycle. Software development lifecycle. How can you write a software from ideation, from an idea, okay, to become a full stack software from ideation to start? So that is what we call software development lifecycle. Okay, the entire process it will take for you to start with an idea to you finishing a full software product. So that is software development lifecycle. I will tell you what that entails because all through your life as a programmer, you will be working with this software development lifecycle. All right. So, and then we now go into the language proper, how to write the instructions. Like you remember, is a programming language. So you will need to learn the syntax. How do we write the program? How do we compile the program and all that? So you learn a syntax. So if I want to learn English language today, I start from the alphabet, then how to merge those words together to form two-letter words. 3, 4, how to construct grammars. So there's in programming language also, there's also syntax, the grammatical syntax, in writing code, and all that. Okay, so these are brief outline of what we'll be looking at in this course. All right, so please pay attention as we go. So in this slide, you might be asking yourself, why do we use C? Like I've rightly explained earlier, C is very powerful and very flexible. Very powerful, very powerful, and very flexible. We've seen areas of application like operating system. All right. So most of these, your operating system, Windows, Linux, Mac, they are written in C. Okay. Word processor are written in C. When I say word processors, like your text processor, like your notepad, like your wordpad, like your Microsoft Words and all that, applications, basically, most of them are written in C. Graphics, your computer graphics, 90% of computer graphics is done in C. All right, spreadsheet, compiler, and all that. C is preferred by professional programmers. Hence, it has a whole lot of resources for your project. So, most of the time, whenever we want to learn a new language, we want to know if there are resources there, if there are questions and answer. So you ask, oh, how can I carry out this operation? Someone has encountered a problem earlier on, and there are tons of ideas and information online, okay, for you to carry out this. All right. So there are a lot of resources. You can't get lost. All right. C is portable, very portable. All right. So once the program is written for a computer system like Windows, that same program can be recompiled and run on another platform with little or no modification. Okay? With little. So it means it is platform independent. All right. What we do is when you have a particular machine, let's say you have a Mac or AMD machine or Intel machine. Let me say you have an Intel machine. Okay, Intel. You have an Intel machine or Intel processor. Okay, you have an AMD machine, AMD processor. Okay, in your computer, So, and you've written your code in C. Okay, you've written your code in C. All you just have to do is compile the C file, the source code, to this target machine. Now, if you want to now run this code on another platform, on another processor, all you just need to take is to take this your source file and take a compiler, and you recompile it onto this other machine. So it's portable. Okay, you can take the same code rather than you rewriting all the entire code. You just take the same code and recompile it on another machine. Okay, so C is very fast, and it is the preferred language for embedded system. Embedded system. Okay, so you want to write program for the core of your mobile phone, smartwatch, for core of your fridge, AC, right? So those or your toaster machine, okay? You want to write instructions to the processor, then it is C that you will use. It's used to communicate with the hardware, okay? And it's also used to develop software a lot. So I hope with this brief explanation, you are convinced that writing in C is very important, or learning in C is very important. All right. So now we want to quickly look at what we call the software development life cycle. Software development life cycle. Okay, software development life cycle. How to write a program from ideation, from your idea, okay, from idea to a full program. All right. Or what are the steps in writing a program? If I want to write a program today, what are the steps for me to write those programs? Number one, the first thing you need to do is to understand the program objective. Okay, the program objective and the requirements. What am I asked to do? What software do we want to write? What would be the requirement? Okay, what are the functions it is expected to carry out? So it is very important for you to understand the program what objective and what the program requirements. All right. So as a programmer, sometimes you might not be the one writing the program yourself, as in having the idea. You might have a customer or a client come to you and tell you, programmer this, Sam, I want you to help me write a program that solves this particular problem. So you sit down at the round table, okay, with your client, and the client will tell you everything he or she needs. Sometimes in the software development stage or the understanding stage, sometimes we have several parties that come into play. So let me say this. If I want to write an application for bank, okay, do I need to just sit down and just imagine all the software would do? Who are the parties that should be at the round table or at the discussion table to develop this software? I'm asking. So who are those that should be at the round table to discuss the software? Anyone? You can comment. Yes, Toluwalashe, please unmute yourself. You can unmute yourself, Toluwalashe. I can't hear you. Your hand is raised up. Is there any other person that wants to contribute?
Good evening, sir.
Yeah, evening.
Okay. So like the people, when a software wants to be, so I say software.
Yes.
Okay, so like when a software wants to be developed, people that should be on the round table should be like the developer, that is the programmer.
Yes.
Then probably the project manager, person that will
Yes.
manage the whole project development, the owner of the project, that is the clients themselves.
Yes. Yes.
And
Yes.
that should be all. Because
Yeah.
it's the projects, yeah, that should be all.
Okay. That's wonderful. I love that. I love that. So one of you build a team. Before you build your own team, you have to interface with the client to understand what they are trying to develop. So sometimes, let's say if it's an accounting package, then I might interface with the people in the accounting sector or in that particular organization. They'll tell me all the requirements, what they want to see in their project. Okay, so let's say they want to um, always pay premium. Maybe it's an insurance, so they will say, oh, maybe there will be a particular tab or a particular GUI where they tell us, okay, we must know this the customer's name, this customer premium ID, the customer's vehicle or premium product, the number of years this customer has been paying. You know, they will give you all the requirements, and as a developer, you note all this because you are trying to develop a software that meets the client's requirement and expectation. So you get all this. So after you've gotten all this, you are able to get all this. Sometimes in your software development life cycle, there might be some information you did not get properly. You might interface with the client often and often till everything evolved to a particular product. So it's not that one time is a one-time interaction. I just interact with the client once and that's all. No. Sometimes as you are interacting with them, you develop your products you are developing, still in the developmental stage. You present the stages. Oh, this is what we have as of now. They look at it, they make some correction, they'll tell you, oh, this color does not match, this is not the data field we want, this is not the data type, and all that. Okay, so your understanding of program objectives and requirements is the first step. Okay, so when you now, as a developer, you now go back to the office, maybe you are the project manager or the team lead, you get back to your office, you call your team of developers um, um, at the round table. So sometimes you would have a whiteboard, telling them, oh, the entire program scope. Then you start analyzing, okay? You start analyzing all the problem using some algorithm. So, has anyone heard of the word algorithm before? Have you heard of the word algorithm
Yes, sir.
before?
Yes, sir.
Uh,
Yes,
okay. I
yes,
think I
sir.
love this.
yes,
I think I love this class. I love this class because some of you are already knowledgeable, and I tell you, this is the digital world. Okay. So, and what is algorithm, if I may ask?
Um, an algorithm can be defined as
Step
a
by step
step-by-step procedure
procedure
solving a
of
particular
the
problem with a given number of steps.
Okay, that's wonderful. That is wonderful, wonderful. Thank you so much. So the algorithm is step-by-step instruction of procedure in carrying out a particular task. Now, imagine your algorithm like a cookbook or recipe book. If I have to bake a cake, most of if you've related with the bakers, they always have this book, this manual. They will tell you, oh, if you have to make a cake, okay, number one, have your um box or your container, put your flour there, measure the flour. Please kindly mute yourself whenever you join my class. Okay. So they tell you, oh, you have a container or a vase. Then they tell you, oh, put 20, 10 kg or 5 kg or measure 5 kg of flour. That's step one. 5 kg of flour, pour it there. Take two eggs, crack it, pour pour it there. They might tell you, oh, remove the yolk. Depending on the steps, they'll write, okay, whisk it together. After whisking it together, um, and make it evenly fluffy. They can tell you put it on the pan, or can tell you, oh, put the flour on the table. Okay, then take just rolling rolling wood or whatsoever, try to spread it out, put it inside the oven, after 10 minutes, bring it out, you add so many things. So basically, if you've seen a cookbook or a recipe book, right, they have some series of instructions which you carry out to be able to achieve a particular what? A particular step. So let's say I have a banking app I want to create or an ATM app. Then I'll say, okay, maybe I will have an interface to ask the user to plug in their card. So they input your ATM card. So after slotting the ATM card, there's a controller that checks, oh, is this card valid? Okay, if the card is valid, then ask the user for PIN, for their ATM PIN. If the ATM PIN is correct, now when we say correct, it means it has to verify with the bank server. If it is correct, then ask it how much do you want to withdraw or what transaction. You can see those step by step. You first of all break the complex problem into step by step, or you go through a modular approach. A modular approach in the sense that a complex piece of work, you have to break them into sub-components. Okay? And when you finish, writing those sub-components, maybe into functions, you then merge them together to get the entire software. Okay, so let's say I want to, my end goal is to prepare coconut rice, or let's say rice and stew. Okay, that's the end game, and that is a product. Okay, I now break them into two different components. Rice, prepare my rice. Another step to prepare the stew. I break them down, and at the end of the day, I merge them together. So it becomes more like a Lego block, which I then fix together to form an entire product. So one thing about the algorithm is algorithms are finite. Your instruction must not be forever. Okay? Your instructions are finite. It also always have a start instruction and an end instruction. It's not, there should be no program that does not terminate. Okay? Your algorithm must be finite. Your algorithm must work on certain set of data. Okay? What are the data I'm going to be passing to this? You ask yourself, what data do I need? How do I represent it? Do I attack it in object-oriented way or in sequential style? Okay? Then I write it in pseudocode, just in layman's language, devoid of any programming syntax. Okay? And maybe I can use what we call a flowchart. So a flowchart is just a graphical representation of how your program works. So what we do, let me say I want to compute, say, equals A plus B. Let's say that is the task I am given. So one way you can do this is you can write it in a pseudocode. You can say, ask the user to input A, ask the user to input A, okay? Ask the user to input variable B, or depending on your algorithm, you can say define a variable called A, okay? Declare a variable called A, declare another variable called B and C, all right? Ask the user to input the value for A, B, and you cannot input for C, okay? So when I get the value for A and B, then write an equation to add A plus B. The result should now be placed in C. You can see the step-by-step way which I've written it. So in pseudocode, you are writing your steps in an English-like format, okay? In an English-like format, devoid of any language. So the same thing that I can have asked you, let me use Notepad. No, Notepad. So let's say I want to compute C plus A. So if I want to do that, my Sudoku can say declare variables A, comma B, and C. So those variables, I will explain what variables mean. They are more like a container that you can store your values. Okay. Then ask the user, my step could be ask the user to input values for A and B. Okay. So I will ask the user to input value from A and B. Then I will write a formula to say C equals the addition of A plus B. So I can write the formula adding A plus B. Then I can say place the value of A and B in C. Then maybe print out the value of C. Then for every program, you must always stop. So a program has a start and also a stop. So this could be a pseudocode to guide you to be able to write a program. Let me tell you one thing. Once you can figure out your algorithm, once you understand the process flow, what am I asked to do? I tell you the fact you can attack any problem. Thank you, Precious. Igbaye Shemori. Thank you. You understand? Once you understand the algorithm, what am I asked to do? What variables will I be creating? Okay, what will this function be doing? If you can do that, you understand your algorithm, then you can write any program. You can write any program. Okay, it's very, 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 very important. Most students don't know how to tackle their problem. Okay, now another thing I wish you to know is when you are asked to write program, you don't just jump into the idea, or you don't just jump right in the instruction, the program. No, you need to first of all understand the program objective, know how you tackle it. Okay, just like I tell my students, you write program every day. You don't just do things arbitrarily. Okay, you are more like a working computer with a program. All right. So look at this. If I wake up in the morning and I want to take my bath, the first thing I ask myself is, oh, is there water running in the tap? If there's no water running in the tap, what should I do? So the end goal is to take my bath. But I need to take care of several scenarios. Is there water running? There's no water. What should I do? Okay, maybe I have to go and pump on the pumping machine, or go and fetch water from the well, from from the neighbors, or from I have a reservoir somewhere. Okay, once you can able to tackle it, I want to eat. Okay, what should I do? Do I have food at home? Is there gas? If there's no gas, can I fill it? If I can't fill it, it means I should eat out. Once you can analyze your problem or your requirements with the end goal in view, then you can write any program. We do this all the time. If it is raining, what should I do? I pick up an umbrella. Once it is not raining, what should I do? I drop the umbrella. So your algorithm, I tell you the fact, if you are a novice, and you take up a chef recipe book and you follow the chef's recipe book judiciously, it will definitely give you a successful or almost successful product. Okay, so your algorithm then translate to what we call program development. Then you start writing the program. Okay. So there's something I need to just say before I move on. What I have to say is this. You could write your your algorithm in pseudocode just like this in human language, program agnostic. Yeah, it's not tied to any program. Okay. Or you can write it in something like flowchart. There's also something called UML diagram, Unified Modeling Language. Okay, UML, please. It's good for you to read up. Okay, some representations are like this. I don't know if some of you have seen something like this. You see the actors. They'll say, oh, input, input. Um, you know, you have this diagram. You have the actors, okay, and the role they have to perform. Okay, that's another representation. Okay, so in the flow chart, this is how flow chart will be. You always have a graphical representation. Is a chart that flows more like there is a sequential way of it flowing. So you can say input A plus B. And so in flow chart, they use symbols. Input variable A, okay, variable A, B, and C. For now, you might not input. Maybe the first thing you do is declare variable A, B, and C. Declare variable A, B, and C. You understand? That's where you start from. Then ask the user to input A, comma B, comma C. You understand? So sometimes, sometimes we have some charts, some diagrams to make decision, something like this, a diamond shape to make decision. Okay, and we'll say is A greater than B? Is A greater than B? Sometimes, if your instruction is to compare two variables, is A greater than B? If it is yes, move to this instruction. So you'll see something that writes yes. If it is no, maybe print. If it is no, so you will see something like if it is no, maybe display B is greater than A. Then at the end of the day, you have to stop. I don't want to. You have to stop. Okay. So stop is depicted with a circle. With a circle. All right. So I don't want to go further in, but some of you might have seen a chart like this. Has anyone seen a chart like this? Sorry, my laptop is misbehaving. A chart like this. Has anyone seen a chart like this? So
Yes,
that's
sir.
what
Yes,
we
sir.
call it a flow chart. You
Yes.
start. So we have a shape to start. You understand? Shape to make a diamond shape to make decision. A circular shape to stop. To input. Sometimes you have a trapezium or a parallelogram to maybe for declaring variables. Okay, so you could have a representation like this. Okay, in flowchart or in pseudocode, just like this, or in UML state where you have actors, okay, um, um, and the machines, okay, the state actors in it. Okay, so that's how to write. You represent. Like I told you, you don't just start programming. You don't start programming. Okay, you already understood how to go from A to Z before you start. Then, after you've rightly understood what you're doing, then you move on to what we call program development, where you really write your program. You really write your program in any language. in a suitable language of your choice. Not all language are used or are suitable. Just like this, if I have to develop a web application or maybe create a website, I won't use C++. I can use C++ to create a website, but it's not ideal. So I use HTML language to do that. Okay, so you use the language of your choice to be able to write. So at this particular stage, you are already coding. You are coding here. You are coding. You are writing instructions. Okay. To the computer, you are writing instructions. So for every instruction you write, when you are done writing, then you have to test. You have to test. And in the testing stage, you have to carry out what we call debugs. I tell you, if you are writing a large scale application, you will definitely make mistake. So the errors you will find is what we call in computer language bugs. So the errors you find are what we call bugs, and um, this stems from um, issues that happened in the past. There was a time where we are using mainframe computers. Computers were as big, and it spans a large building. Okay, and those transistors, all our switching devices are maybe valve, and we are having a rotating knob to switch between zeros and one. So when they developed or when they brought those computers, then there was a bug, more like a fly, okay, that entered into the machine and stopped the operation. It's just like when a rat, you know, enters into your machine, and um, eats your wire or dies inside and does not make your machine perform. And so when they remove the bug, and that's where the terms originated from. So when you remove the bug, that's what we call debugging. You are debugging. All right. So that's that. Okay. Remember, there's something I want you to know, that in your development, software development stage, um, understanding the problem and representing it um, might take you something like 30% of your time. 30% of your time. Understanding might take you 30% of your time. The actual programming might take you 20%, or it can be reversed. Sorry, 20% of your time. Testing and debugging takes huge number of time. It can take you 40% of your time. 40. Okay? And documentation might take you 10% of your time. Okay? So it's the most of your time always go into what? Into testing, because you have to rigorously test. There are some people we call software tester. Whenever Microsoft or any tech company or any fintech company, any top company at all want to release any product, there's what we call product testing or quality assurance testing. They subject it to rigorous testing. Even your mobile phone, your keypad, your laptop, all these keypads are rigorously tested that they are working. They will test every keys. Okay? They will test every knob, every switch, everything will be tested to see if they are working. Remember, so it is when it certifies or pass the quality assurance test that it moves on, it goes out to the public. Okay? It goes out to the public. Have you ever had instances whereby cars that is already sold to the customers are being what? Are being returned back? You will hear that, Cybertruck, Tesla's Cybertruck has been recalled back to the original onto the company. Have you ever had something like that? Okay, so doing your testing, doing software testing, you might not capture everything. You might not capture everything because if you wait till you have a fully fledged, highly 100% proof, and there's nothing called 100% proof software. There's nothing called like that. Okay, your software is as rigorous or as robust to its usage. You will see someone that would discover one thing or the other that you fail to look at, even with your with several software testers. Okay, so some people will test it. If I'm testing this Zoom app, I will speak to it, the microphone. If there's a microphone section, I will speak to it. I will mute it if it works. Does it work? Okay, I mute. If I can connect external microphone to it, can I change the audio interface, input interface, or microphone? The video, I have to test the video. If I press the video, will student be able to see me with my camera come on? Okay, it works. Can I off it? Will it work? How many participants? Can I interface other medium? So you test, rigorous testing. So not everyone will be a software programmer in this software ecosystem. Some are just the, um, some are programmers, some are testers, some are the project manager, some are quality assurance. We have a lot. Okay, we have a lot in the software ecosystem. Okay, so after you've tested, you do documentation. For every software, there's always a documentation aspect of it that guides the user how to use it. Okay, if you press F1, you always see help in every program. Have you guys noticed that? You always see help, how to use. Okay, or sometimes they release a manual for you. Those are documentation. And the last thing is maintenance. So you need to always maintain your code. If an error is spotted, you maintain, the programmers have to fix the error, release the update to the public to download. And so those are just short-time maintenance. But however, for feature release, okay, newer features, the customers will be asking for newer features. Those newer features will be added to the program and released as version 2, version 3, version 4, and all that. So software maintenance is more like forever. You will always keep maintaining the software, making it robust, resilient. Before you know it, it will be a very huge, robust software. So basically, these are the steps for you to write any program, and in any language. You always have to go through this process. There's so much to software development. Software development is an entire course on its own. You understand? So it's an entire course on its own, and I won't want to go too much into that. I hope you guys are following and you understood all I've taught. If yes, in the chat box, kindly respond. And also everyone online here right now, put your name and your matric number in the chat box. Everyone right now, put your name and your matric number on the chat box. I saw people left the class.
Oh my God.
So your name, and your matric number there. All right, so let's move on. Sorry. So, how do we write program in C? How do we write program in C? Now, for us to write a program in C, what we do is we use what we call a text editor. Please, I want you to pay attention. You use a text editor to write your source code. Let me give you an example. I hope you can still see my screen. Anyone, can you see my screen?
Yes, sir.
All right. You use a text editor. So your text editor could be as simple as Notepad, okay? WordPad, Notepad++, Notepad++, okay? It could be as simple as just those basic text editor, and you write your code in those text editor. So let me just give you an example. So I could write my program. Look at this now. I could write my program in a text editor and just say hash include stdio.h, something like this, and say int main. I'm just int main. Okay. So you can come here and say, okay, return 0. I can come here and just say, okay, print f to hello world. There's somewhere I'm going with all this gibberish I'm writing on the screen. Okay, so if I use a text editor, I want you guys to follow me because I want to deconstruct certain things to you. So I could use a text editor like a Notepad, WordPad, Notepad++, okay, and I'll save it. Let me save it and say it should be test.c. Okay. Any program you write in C, a C program, you have to end it with .c. So the compiler knows it's a C program. Sorry, my trackpad is misbehaving. So you can save it as dot. So you must know where you're saving it. So let's just say I saved it on my desktop. So let's just say I've saved this on my desktop. Apologies, my trackpad is not functioning. So if I go to my desktop, you can see that the screen here shows test.c. Okay, test.c. You can see the system recognizes it as a C. I can then open that same with maybe Notepad++ and back to my code. Then if I have this, okay, I can then compile it into an executable code. All right. So let me delete it. I want to show you certain things. There's a Linux command there's a app called WSL, Windows Subsystem for Linux. I want to use that to illustrate my points for you, and please pay attention. Okay, so this will give me more like a Linux feel. All right, so I can use my command, change it to my home directory. I can say ls show me what I have. So I can display what I have using a command called dara.c. Look at it, dara.c. Okay, this is what I have in dara.c. So I can create a text editor. I can use a text editor to write a program. So I can use a text editor like Nano and say Samuel.c. Samuel.c. So Samuel.c is my source file. Okay, Samuel.c. So with this Nano, I can come here and write the same program, hash include stdio.h. Okay, let me come down. It's main, my main function. Please don't disturb yourself if you don't understand this. You will understand all the syntax as time goes on. So I can say, welcome to C programming class. Please, like I said, don't disturb yourself. Come to a new line. Say maybe a new line and say, I love C. I love C. Okay, I love C. I close it. Okay, sorry. I love C. Okay, then you can say return 0, come and close it. So I've written my instruction. So basically, I've written my instruction using a text editor. I wrote it in a text editor, then I can save it. How do I save it? This one is saying Control X. So I write Control X. It says save modified buffer. Yes, I want to save it. And write to Samuel.c. Yes. So then I can go to Samuel.c. Please don't mind what I'm doing. Just follow what I'm. So I can say, let me see the content of Samuel.c. So you can see in Samuel.c the instruction I wrote. Okay. So what thing I've been able to do is I have a file, okay, called Samuel.c, which my instructions are written. Then I will use a compiler, a software called a compiler, to compile this file into what we call an executable to make it run. An executable what? File. Okay. All our tasks in this course is we will write our code in C in high level, and we will use a compiler to compile it to become an executable. Then with this executable, we can run it and our computer will carry out the instructions. Okay, so please just bear with me. After writing my instruction, I can use a compiler and say GCC compile Samuel.c maybe to main, or we can just say main. Okay, let's just say compile Samuel.c. Okay, so it's wrong. Then I can say a.out. By the time I click on a.out, what do I have? Welcome to C programming. I love C. Can you see that? Let me clear. I can just say a.out. I'm running this executable now. A.out. What did it say? Can someone see the output?
Okay. Welcome to C programming. I love C.
Can you see? I wrote a program to the machine. I compile it. I'm running it. So basically, that's it. So I wrote my instruction in a source file, Samuel.c. I use another application. So I exited the text editor, right? And I use another application called a compiler to help me compile the code to run. So you can see they are in separate environments. Is that taken? That should be clear. Do you understand that?
Yes, sir.
Yeah, okay. However, we have what we call IDs. I would explain that. We have what we call IDs that helps us to compile all this, and we can write everything in that same environment and compile it. I will explain. So please pay attention. There's what we call text editor, which I showed you the other time, where you just like your notepad, where you can write your instruction. Then, and when you use your text editor, inside your text editor, you have your source code, the instruction. Then you compile the source file. You use a compiler like the GCC, that's a GNU compiler, okay, to compile that source file, or the source code, because computer does not understand those welcome print function. It doesn't understand. All it understands is what? Machine language, zeros and ones. So you need someone called a compiler to help you compile it, which it compiles from the source code to an object code. Then there's also another software internally called a linker that will link several other library files. Remember that when I wrote my program, I said include, more like import into this environment, attach into this environment, stdio. Do you understand? And with this stdio.h, I was able to carry out my print function. I did not write this print function. Someone wrote it. I'm importing it. All right. So this library file, the stdio, contains the print function. It combines it with the object code to give me what? An executable program, which can be run on my machine, which I finally ran on my what? On my machine. Okay, so you can see how I've been able to write my program. I used a text editor. Can someone say text editor?
Text editor.
So the
Text
text editor,
editor.
Text editor.
yes, it gives you a canvas where you can type your code. So if you're an artist, it's a canvas where you can paint, right? Inside the text editor, you can write your commands, your instructions. Okay. So you can see that, but there's something called ID. Your ID called like your code blocks. I want to show you. The IDs, we call IDs what? Integrated development environment. Again, integrated development environment is an environment where you can develop programs and all the features you need is integrated. Again, IDs means integrated development environment. It's an environment or an application where all that is suitable for development and all you need has been integrated in it. I want to quickly show you what I mean, and we'll be using IDs in this class. It's an introductory class. All right. Apologies, my system needs upgrade, so that's why it's a bit slow. But let's see how this particular ID. I have several IDs, and I will tell you the one which we'll be using for this course. Look at it. Let's look at this. Apologies. So let's create a new project. It believes that everything you want to do is more like a new project. You click on a new project and come to console application. Click on the console application. Please always mute yourself. Always mute yourself. So in the console application, it asks me, what language do you want to use? Do you want to use C, C++? There are some IDs that have several languages. Okay, it can ask you, do you want C#, Q basic, F basic, do you want Python? Okay, so I'll have to tell it, oh, I just want to use C. Then tells me what would be the project name. So let me call it test. I've always used test. So if I click next, it will. So you will see the resulting file name is test.c. But let me use Samuel. Samuel, the rep. Samuel. So it will create a folder for me, you understand? And the project file name, where it's saving it. I want you to know this as a rule of thumb. Every time you're creating your project, okay, always know where you are saving it, the directory, the folder location you are saving it. It's very, very important. Okay. So you will see that this code block created for me Samuel.cpp code blocks, and it will tell me which compiler do I want to use. So I will leave it with the default GNU GCC compiler, the one I use, just like the one I use in the WSL Linux environment. I click finish. Then I can come here. I can come here and click on the sources. You will see main.c. And here in this environment, I can type my instructions. Yeah, I can type my code. The beautiful thing I love about code block is beginner friendly. It gives you a minimalistic set of commands for you to start running. All right. So it gives you your main function. It includes some standard libraries, your standard IO, minimalistic. Okay. So the first instruction that can always come by default here is hello world. So you can change it and say hello Samuel. Samuel. Okay. When you're done, now pay attention. Um, remember that previously, whenever I write my instruction, I will save it and I will exit and go to my terminal and write GCC, more like my compiler to compile that code for me. However, in this environment, look at it. It has all the features I need. This is where I can write my code. I write my code, add more files. I can add more files to it. You understand? I can click here and say more like add files. I can add more files to it. I can remove files. I can delete. I can do all sorts. Okay? Everything is integrated here. I don't need to go outside of this environment and save and come back. No. All I just do is I can come here and click on this button, build, run, build and run. So I can build and not run. You understand? I can build and run. So you can just come here and click on build and run. Everything is integrated. So you can see my instruction, my code running. Hello what? Hello Samuel. This is your first code. Okay. Hello Samuel. All right. I can come here, copy the same, modify it, come back and say, hello Samuel, hello Samuel, hello Samuel. Wonderful. I'm writing instruction to the computer. Hello Samuel, hello Samuel, hello Samuel. Okay. I could do a whole lot of things in programming. You could do a whole lot of things. Okay. Okay. So I can never mind any instruction I'm writing now. Okay. And do this to populate my screen. You can see it's running hello Samuel 500 times. Hello Samuel, hello Samuel. Like when I scroll up, you will see 500 times. Hello Samuel. So basically, you are the one to write instruction to the computer. the computer does not understand anything. It is whatever you write to the computer that it will give to you. Okay? And that is why we use this word garbage in, garbage out. Whatever garbage you put in, whatever instruction you give it, that's what it will give out. So you can't tell the compiler or the computer to read your mind. It cannot read your mind. Okay? Whatever you ask the computer to do, that is what it will do. So if you're not getting your desired result, you need to ask yourself, have I written the right code to this into this computer? All right. So it's very important for us to understand that this is what we call an ID. Everything is integrated for us to write our program. All right. So there are several IDs available. Microsoft Windows Studio Code, VS Code. You can see PyCharm. You can see Anaconda. You can see Notepad++. There are several where you can actually write your code and you have to compile. But basically, you need to understand that all you are doing is you're writing a source file. You're writing a source file using a text editor, and you're actually compiling it and linking it to give me what? An executable, So your program always have some errors. This is always blocking. If let's say, so if you have to write program, one of those things you will start learning in this course is what we call syntax. Syntax. One of the syntax is just, this is how the compiler understand. This is how the language must be written. If you omit anything, it would give you an error called syntax error. And I want to quickly start showing you how to start debugging. You will always make error, but your ability to debug. Okay, so let's imagine in C, every instruction you give, every line must end with a semicolon, every instruction. So let's say I forgot to put a semicolon and I decide to run it. You will see that it will not execute. Rather, it will debug and tell me where error is. Can someone see my terminal, this build message down below here?
Yes, sir.
So can you tell me what it's saying? It's saying what?
Expected a semicolon before the curly
The
braces.
curly braces. Yes,
Yeah.
the closing. So it's saying I'm expecting a semicolon. Do you know the beautiful thing about using these IDs is it tells you where exactly it is. So if you double click on this, it will give you this. You can see this red marker telling you before year. What is before? It means in this region, right? In this line 8. In this line 8, which is before this semicolon, this should be, every statement, whenever we write a statement or a sentence, we put a full stop, right? So the semicolon is more like a full stop. I'm done writing. The compiler is aware. Okay. So once I run it, no more problem. Okay. There's something I wish you guys paid attention to. Let me see. There's something, just a minute. Good, good, good. This is what I wanted to show you. If you look at this build log, okay, you can see the compiler GCC compiler Ming GW Ming W32 GCC. You can see dash wall. All this has a meaning. And what you're trying to run, look at it. I'm running what? This file. This is the file I'm running. Main.c. This is the file main.c. This main.c, that's what I'm running. This is just the full part where it's saved. You should output it and it should become main.o. Okay, so at the end of the day, you see the output file is here as Samuel dot what executable. It can run. It's an executable code. Okay, so that's what I want to show you. That behind the scene, what I showed you in the WSL Linux command, that's what is being done here also. But you know, when you use GUI, you don't sometimes see what happens behind the scene. Okay, so I think I will stop here. I will stop here because we've had a very good introduction. The next time we will see, we'll be looking at how to write our code, components of how to write our code. That's what we'll be looking at, starting from the next class. I want to ask, is there any question before we move on? Any question, any clarification needed? Anyone? All right.
Yes.
Now, if you're saying
What
yes,
are the
then
examples?
continue asking your question, or you put it in the chat box.
What are the examples of embedded systems?
Number one, that is not what I'm teaching, but actually, embedded systems are systems where you put, let's say, your controllers. Okay, you embed your processor in it. Examples of embedded system: your mobile phone is an example of embedded system. Okay, looking at your AC, an example of IoT applications as embedded system. Okay, in it. In your mixer at home, your energy meter at home as an example of embedded system. Okay, systems where you can embed a processor into it. Your smartwatch is an example of embedded system. Some of these questions, just go online and ask the. So let's say examples. So I want you guys to always be a researcher. Examples of embedded. So you'll see a specialized computer system, because most of the time whenever we talk about computer system, all we tend to know is, oh, it is only my laptop or my server that's embedded, that's computer. Okay, your fitness tracker, your smartphone, traffic light, all these things, that anything that have a microprocessor or microcontroller in it, then you understand. Sometimes your toy, your Christmas toy, you open some Christmas card, it starts singing happy birthday, or is Santa Claus. Santa Claus is coming to town. Or in your car, okay, in your car with your GPS tracker. You understand? All these, your airplane, all these have, so ranging from microcontrollers, tiny microcontrollers and toys, to complex systems like aircraft, medical devices. Okay, you go to the hospital, you have devices plugged to patients' hand and raise ECG, endocardiac readings. Okay, you know, tracking the pulse. These are embedded systems. Okay, microwave, your PS5, your gaming console, airbags, infotainment, engine control. These are embedded systems. So always try. All these are online for you. Any other question before we call it a day? Question, guys? You can put it in the chat box. Are you with me? Are you guys still with me?
Yes, sir.
Yes, sir.
Okay. In the absence of question, we'll call it a day. Is there anyone asking a question?
Yes, sir.
Please, fire on.
You guys can hear me. Oh, so I'm sorry, sir. What you were saying something about object file. Can you please give us more light on that?
I could have given you as a reading assignment. Okay, so let me just explain. In the compilation stage, there are about 3 stages. You have your source file in .c. Maybe I should use that. But that's a good question, actually. So if you have your source file in and is in .c, you understand? The compilation stage always takes some steps. Okay, it compiles this .c file to what we call an assembly file, which is .s. Okay, and then compile it to what we call an object file. In the object file, which is .o, the object file is more like the machine. Is more like the machine instruction, the binary equivalent for that target machine. Like I told you, for an Intel machine, the instruction set for that machine differs from an AMD. The way it is written, the way the architecture, the way it is developed is different from AMD, is different from any mixed machine. Okay, so the object file is more like the binary equivalent, more like, okay, for what? For that target machine. So what happens then is, after with this object file, the linker links these several object files together to give you one executable file. Okay, so that is that about object file. Okay, the final end product, if you're on Linux on a Windows machine, is an executable file. Even is your Linux is also an executable file, but maybe in a.out. Okay, so that is what I will tell you. You can read on. Is that understood?
Yes, sir.
Yes, sir.
Any other question? Any other question? Okay, so this is where we stop for today, and hopefully, I won't say hopefully for the year. Let's say, yeah, for the year. Next week is 25th. So, and for the year also. We see next year by God's grace. Enjoy yourself. Enjoy your holiday. Read more, and stay blessed. Bye.
Amen. Thank you very much, sir. Bye-bye, sir.
It's good to have you. Bye.
Thank you very much, sir.
Yeah, bye.